Welcome to Get Cooking in Cloud, where we share the best recipes to apply in your cloud kitchen. I'm Priyanka Vergadia, and in this episode, we will talk about scaling a web application on Google Compute Engine. As we learned in our Compute Engine example, when web apps are deployed on GCE instances, deployment and scaling is done automatically and seamlessly by using instance templates. When your website becomes popular and the users grow from 1 to 1 million, you need to add instances, and when the requests go back down, you need to remove those instances to keep the costs low. But how does adding and removing instances automatically work? Compute Engine Autoscaling Policies. Autoscaling is one of the features of managed instance groups. Managed instance groups allow you to operate applications on multiple identical virtual machines based on instance templates. You can make your workload scalable and highly available by taking advantage of automated managed instance group services, including autoscaling, auto-healing, regional deployments, and auto-updating. But wait, what is an instance template? An instance template is a specific, customized configuration of the GCE instance that facilitates the reuse of instance configurations by using managed instance groups. This custom image then becomes the starting point for future deployments. Now, back to autoscaling policies. Autoscaling policies provides a way to add or remove instances as needed. The impact of autoscaling policies is twofold. One, your users get a great experience using your application because there are always enough resources to meet the demand. And two, you maintain better control over your cost because the autoscaler removes the instances when demand falls below a specific threshold. To create an autoscaler, you must specify the autoscaling policy and a target utilization level that the autoscaler uses to determine when to scale the group. You can choose to scale using average CPU utilization, stack driver monitoring metrics, or HTTP load balancing serving capacity, which can be based on either utilization or requests per second. The autoscaler continuously collects usage information based on the policy, compares the actual utilization to your desired target utilization, and determines if the group needs to be scaled up or down. For example, if you scale based on CPU utilization, you can set your target utilization level at 80%, and the autoscaler will poll for the CPU utilization and check if it is more than 80%. If so, it adds the new instance to the instance group. If the CPU utilization is less than 80%, then it removes an instance from the group, making sure the capacity is always maintained. You can use autoscaling in conjunction with load balancing by setting up an autoscaler that scales based on the load of your instances. For example, assume the load balancing serving capacity of a managed instance group is defined as 100 requests per second per instance. If you create an autoscaler with HTTP load balancing policy and set it to maintain a target utilization level of 80%, the autoscaler will add or remove instances from a managed instance group to maintain 80% of the serving capacity, or 80 requests per second per instance. Now, our architecture needs to automatically replace instances that have failed or have become unavailable. And when the new instance comes online, it should understand its role in the system, it should configure itself automatically, and should discover any of the dependencies, and it should start handling requests automatically. To replace a failed instance automatically, we can use several Compute Engine components together. You could create instance templates that use a public image and a startup script to prepare the instance after it starts running. But we recommend that you use deterministic instance templates, which minimizes risks and unexpected behavior from your instance templates. Thanks to managed instance groups, now we have a system that can replace unhealthy instances with new ones. But we still have a challenge. How are we going to know which instance to replace? Well, for that, we need to define what is an unhealthy instance. And to do that, we use health checks. We recommend that you use separate health checks for load balancing and for auto-healing. Auto-healing health checks are set up at the managed instance group level. You create a health check that looks for a response on port 80, and that can tolerate some failure before it marks instance as unhealthy and causes them to be recreated. In this example, an instance is marked as healthy if it returns successfully 2 times. It is marked as unhealthy if it returns unsuccessful 3 consecutive times. We learned some tricks to make your web application resilient by spinning up new instances and taking them down if compute resources fail or your traffic grows. That's all for today on Get Cooking in Cloud. Here's hoping you can whip up something great. Join us next time where we will see a journey of a startup from a few users to thousands of users and how they evolved their web application architecture to meet the growing and changing needs. If you like this video, then check out the previous episodes too. And to see more such content, don't forget to like and subscribe to our channel.